Some of the most terrifying creatures to ever exist on this planet are often found in prehistoric North and South America, particularly in the late Cretaceous period. This is one of the craziest times in history that Mother Nature decided to push the boundaries of evolution. An era that was largely dominated by giant deadly predators like the Tyrannosaurids, a family of large, carnivorous theropod dinosaurs known for their powerful jaws and sharp teeth, and existed on only 2 continents. And because of these and many other deadly animals, we usually don't stop to think about the other fairly terrifying creatures that also existed in different times in history. And one of such forgotten animals is the Gigantopithecus, the real-life King Kong you've probably never heard about. This prehistoric titan roamed the Earth during the Pleistocene epoch, between 2.6 million and 11,700 years ago. And for reasons I'll soon reveal, the discovery of Gigantopithecus stands as one of the most astonishing and entirely accidental stories in the history of paleontology. In 1935, a German paleontologist named Gustav Heinrich Ralph von Koenigswald made the first discovery of Gigantopithecus in a very unexpected place, a traditional Chinese pharmacy in Hong Kong. These pharmacies often stocked what they called dragon bones or lung goo, which were actually fossilized animal bones and teeth, believed to have medicinal properties. While browsing through these materials, von Koenigswald noticed an unusually large molar tooth, a tooth which is basically similar to the large flat ones you have towards the back of your mouth. But this one didn't match any known species, not even that of a dragon, as the local pharmacist believed it to be. So he made a trade with the pharmacist and continued searching through other shops, hoping to find more, which he eventually did. He collected a few more unusually large and mysterious molars, studied them, and made a shocking discovery. These teeth belonged to an unknown giant ape, unlike anything ever recorded in history. But unfortunately for us as paleo lovers, this is where most of the story ends. After the initial discovery in 1935 by von Koenigswald, many more Gigantopithecus fossils were found, mostly in southern China and parts of Southeast Asia, especially Vietnam and Thailand. However, despite all these later discoveries, no complete skeleton has ever been found, only teeth and partial jawbones. This obviously raises a ton of crucial questions, like, where is the rest of Gigantopithecus' skeleton? How big was it? What did it look like? Was it a really massive gorilla or something entirely different? Did it hunt? And if so, what exactly was on its menu? Or did it forage? And what kind of vegetation sustained such a colossal primate? And if we do have answers to all these questions, how did we even figure them out? What clues did this prehistoric giant leave behind? Some paleontologists speculated that early humans, Homo erectus to be specific, may have hunted or scavenged the remains of Gigantopithecus, since both species are believed to have overlapped in time and possibly in territory about 2 million to 300,000 years ago. And there is fossil evidence that places Homo erectus in parts of Asia during the same general period when Gigantopithecus existed, leading to theories of interaction. If true, early humans might have competed with the giant ape for food, or even seen it as a source of meat. However, despite the intriguing possibility, no direct evidence has ever been found to confirm this hypothesis. There's also a fair possibility that the remains were scavenged and scattered by predators that existed at the time, such as hyenas, crocodiles, or even the Asian black bears. While this is highly plausible, it doesn't really do the full explanation of the complete absence of larger bones, especially considering the high number of teeth and jaw fragments that have been discovered in different locations. The only believed theory on why we can't seem to find any more fossils apart from teeth and jaw bones is the theory of preservation bias due to environmental conditions. Gigantopithecus lived in dense tropical and subtropical forests across prehistoric southern China, Vietnam, and Thailand, regions known for their humid climate, acidic soils, and heavy rainfall. These conditions are notoriously bad for fossilization. 99% of the time, fossilization only occurs under very specific conditions. The body must be quickly buried in sediment, protected from scavengers, decay, and erosion. In dry deserts or mudslides, this can easily happen. This is why we see a lot of fossilized dinosaurs in places like the Gobi Desert or the Badlands of North America, where dry, sediment-rich environments help preserve entire skeletons. But in tropical forests like this, not so much. The only scientific reason why the teeth survived was because teeth are the hardest, most durable parts of the body, made primarily of enamel, which resist decay and damage much better than any bone in the body. Many of these teeth were found in limestone caves, and that was surely not because Gigantopithecus lived in them, but because their teeth were washed in by water, scavenged by predators, or the caves themselves acted as natural traps, catching and preserving them over time. The most thrilling breakthroughs, however, come from the discovery of the lower jaw fossils that have allowed paleontologists and primatologists to piece together fascinating insights into how exactly Gigantopithecus might have looked or behaved. And because no complete or even partially complete skeleton is known, most of the reconstructions of Gigantopithecus are highly speculative and have evolved over time based on limited fossil evidence, primarily mandibles and teeth. The initial reconstructions portrayed Gigantopithecus as a massive human-like bipedal creature, influenced by anthropologist Franz Weidenreich's 1946 hypothesis that it represented a gigantic phase in human evolution. Weidenreich proposed that Gigantopithecus was a direct ancestor of modern humans, envisioning a lineage from Gigantopithecus to Meganthropus, then considered a human ancestor, to Pithecanthropus, now known as Homo erectus, and finally to modern humans. However, Franz Weidenreich's hypothesis was rejected, mostly due to its contradiction with the Cope-Deparate rule. This evolutionary principle suggests that in linear evolutionary sequences of non-flying animals, species tend to increase in size over time. And at the time Franz Weidenreich proposed his idea, the Cope-Deparate rule was widely accepted as a strong evolutionary trend. His idea that Gigantopithecus, an enormous ape, somehow led to much smaller modern humans was seen as going against this trend. And since his theory lacked strong fossil evidence beyond teeth and jaws, the scientific community found it easier to dismiss his claim as speculative and inconsistent with what was then considered a reliable rule of evolutionary biology. In the mid-20th century, another theory was proposed by anthropologist Grover Krantz to support the idea that Gigantopithecus primarily walked on two legs. Krantz noticed that the jaws of Gigantopithecus became wider toward the back and suggested this was to make space for a windpipe, trachea, but only if the skull sat directly on top of the spine, like in humans. This would mean Gigantopithecus stood upright and walked on two legs. There's no doubt this is an interesting idea to consider. However, if you take a closer look at the jaws of many animals that walk on all fours, like bears, gorillas, and even big cats, you'll pretty much find the same anatomical feature, which weakens the argument that this trait is exclusive to upright walkers. But in subsequent analyses, particularly those examining the morphology of the mandibles and teeth, have led to a significant shift in perspective. The structure of the lower jaw is notably similar to that of modern orangutans, suggesting a closer evolutionary relationship with these apes. This resemblance has led to reconstructions depicting Gigantopithecus as a massive, quadrupedal ape with an orangutan-like appearance, but significantly larger, generally estimated to have stood about 9.8 feet tall, with some sources suggesting it could have been over 10 feet tall, weighing between 440 and 1,200 pounds, which is about 2 times the height of your front door, and as heavy as 3 fully loaded commercial fridges stacked on top of each other. That's how tall Gigantopithecus would have been, towering over any human or modern ape, making it a truly imposing figure in its environment. This depiction is supported by the anatomical similarities in the jawbones and the understanding that such a large primate would likely walk on all fours to support its substantial body mass. These giants came in different variations, the most famous species being Gigantopithecus blacki, which is the largest and the first named species. However, there were other existing species like the Gigantopithecus giganteus. This species is thought to be large, but not as massive as G. blacki. It lived around 8 to 9 million years ago during the Miocene epoch, standing at 5.5 tall and weighed at least 331 pounds. Another species was discovered in India, Gigantopithecus bilaspirensis, which lived approximately 6 million years ago. In general, there was a lot of controversy and some pretty wild theories about this prehistoric giant, especially when it came to its diet. And one of those wild theories was that Gigantopithecus was a cave-dwelling predator. This idea was proposed by Chinese researcher Pei Wencheng in 1957, who based his hypothesis on the discovery of hoofed animal remains found in caves alongside Gigantopithecus fossils. Pei suggested that Gigantopithecus may have hunted and dragged these animals into its cave, just as many predators do. However, this theory has since been refuted due to the ape's dental anatomy, which strongly supports the idea that Gigantopithecus was herbivorous. The molars of Gigantopithecus have the thickest enamel of any known primate, with measurements ranging from 2.5 to 2.9 millimeters, and even exceeding 6 millimeters on the tops of the upper molars. This thick enamel could only be an adaptation from grinding tough, fibrous plant materials. Additionally, the premolars of Gigantopithecus have high crowns and a sturdy build, further supporting the idea that it fed on hard, fibrous vegetation. The incisors and canines also feature extremely long roots, about twice the length of the visible crown, which indicates that these teeth were packed closely together and likely used in a side-to-side grinding motion during chewing, which can be observed from many herbivores. Further evidence comes from the presence of opal phytoliths, microscopic plant silica particles, found on the teeth of Gigantopithecus. These phytoliths are a direct sign that this mysterious giant ape consumed plants like bamboo and fruits, rather than meat. And I'm not going to lie, the mere idea of Gigantopithecus being a predator is kind of fascinating. Just imagine this massive ape, towering over 10 feet tall, lurking in the shadows of prehistoric Amazon-like forest, silently hunting large prey like a giant primate version of a predator we've only seen in movies. It would be an entirely different image than the peaceful, herbivorous giant we picture today, chewing on bamboo and fruits. And for the most part, when we bring about the topic of extinction, certain events such as asteroid impacts or the introduction of new dangerous species is most likely the answer. But unfortunately, that's not the case for Gigantopithecus. For the past 90 years, since the discovery of the first species, no singular event has been identified to explain how exactly it vanished from the surface of the planet. This has made it extremely difficult for paleontologists to draw any evidence-based conclusions, so they rely on the most reasonable speculations. And 99% of the time, the finger points to us, well, not us like you and me, but our ancestors. Often, early humans are to blame for the extinction of large animals during the Pleistocene, but this speculation didn't stick for the case of Gigantopithecus. Homo erectus, our ancestors, appeared in Southeast Asia around 800,000 years ago, yet Gigantopithecus persisted in the fossil record until about 300,000 years ago. This suggests that both species coexisted for around 500,000 years. If early humans had been the primary cause of Gigantopithecus's extinction, we would expect the giant ape to have disappeared much sooner after Homo erectus arrived. However, since the two species coexisted for such a long time, it implies that early humans may not have had a direct impact on the extinction of Gigantopithecus. This points to other factors, such as environmental changes or the loss of habitat, which is another possible explanation. Some paleontologists suggest that habitat loss due to climate shifts during the Pleistocene epoch might have been a key factor in the extinction of Gigantopithecus. As the climate changed, tropical forests, where Gigantopithecus thrived, contracted, replaced by more open grasslands and arid landscapes. This shift would have drastically reduced the availability of food sources, particularly the fruits and plants the ape depended on. However, while this theory has some merit, there is currently limited evidence to support habitat loss as the primary cause. The fossil record does not show frequent die-offs or significant population declines directly linked to habitat changes. Unless such die-offs occurred over a prolonged period, spanning several hundred or thousands of years, it may not be enough on its own to explain the species' disappearance. Therefore, while habitat loss may have played a role, a more balanced approach would be to consider the variety of smaller factors that likely played a role in the decline of Gigantopithecus. For example, while Homo erectus didn't directly threaten them, Our arrival in Southeast Asia would have definitely increased competition for food and shelter. And as these resources became scarcer, species that couldn't compete well, like Gigantopithecus, would have struggled to survive, especially due to its size. Larger animals need a lot of food to stay healthy, and evidence shows that malnutrition was a problem for these gentle giants. And as food became less and less available, Gigantopithecus would have had trouble finding enough to eat, leading to severe starvation. While we can't say for sure what exactly caused their extinction, it seems likely that a combination of factors like competition, habitat changes, and not enough food led to their gradual disappearance. This process might have happened slowly over time, with their population shrinking until they couldn't survive. Alternatively, a sudden environmental change or disease might have sped up their extinction. In the end, Gigantopithecus likely went extinct because of several challenges working against them. Kindly like the video if you enjoyed it, and as always, I'm DM. See you in the next one.